In a recent video covering some updates to Burp Suite, I talked about the new match and replace Bambdas. However, I didn't fully explain what Bambdas are and how to write them yourself. This was mostly because Bambdas have been part of Burp Suite for over a year now, so I kinda figured a lot of people would already be using them. However, based on feedback I've heard, it sounds like people would at the very least appreciate a Bambda basics video. So here it is. Before we start, and if you're new here, welcome to my channel. I'm Tiberius, and I've been a web app pen tester for over a decade, using Burp Suite my entire career. If you enjoy seeing web application security content, please give this video a like, subscribe to my channel, and of course, leave a comment with your thoughts. Now let's jump right into Bambdas. The name Bambda is a portmanteau comprised of the words burp and lambda. Lambda referencing anonymous functions used by several programming languages for quick throwaway tasks where you don't want to define an actual reusable function. Bambdas are themselves snippets of custom Java code which can be used to enhance certain features of Burp Suite itself. Currently, Bambdas can be used to filter and add custom columns to the proxy and logger histories, as well as creating match and replace rules. However, Portswigger intend to integrate Bambdas across Burp Suite, so expect them to start appearing in other places over the next few years. Now, Bambdas are written in Java, so you will need to know some Java basics, but for the most part, if you're used to C-like syntax, you should be able to write simple Bambdas. It's also worth noting that the Bambda editor in Burp Suite has an autocomplete, so if you start typing, it will give you several possibilities and will display documentation where possible. A few things to note about Java specifically, however. If you want to use a string of characters, you need to surround them with double quotes. You cannot use single quotes for this purpose. Conversely, Java has a char type for a single character, and those require single quotes around the character. Additionally, the Boolean values true and false are both lowercase, and almost everything in Java is, or at least can be, represented by an object, with methods for that object being called using a period. For example, strings of characters are string objects, and the length method counts the number of characters in the string. So this code will return a value of 30. Finally, although Java is a statically typed language, meaning when declaring variables you normally specify the variable type, you can actually use the var keyword to declare a variable without a type, and it will simply be given a type based on the value it is assigned. Honestly though, unless you want to do something super complex with Bambdas, for the most part you can achieve what you need with simple Java code. And I encourage you to just try stuff, see what works, and use the autocomplete feature to learn what else is possible. So, let's actually write some Bambdas in Burp Suite to give you an idea of what you can do. Okay, I'm in Burp Suite Pro version 2024.9.5, and I'm on the Proxy HTTP history tab. As you can see, I've already browsed to ginandjuice.shop, which is Portswigger's test site. I've also visited Google. I also loaded one of the Portswigger Web Academy challenges, and you can see all those requests and responses in the HTTP history. I also added ginandjuice.shop to the target scope tab. Okay, so currently the filter settings basically is just showing all items, right? There's pretty much no filtering going on. If I click the filter settings, you see a window which I imagine if you've been using Burp for a while should seem pretty familiar, right? So we have the settings mode, this is what it's called now, and we also have this new Bambda mode. But let's stay in the settings mode for now. We could, for example, check show only in-scope items. We could filter by MIME type if we wanted to. We could filter by status code. We could filter by some file extensions. You know what? Let's hide JavaScript JavaScript files, GIFs, JPEGs, PNGs, CSS, etc. Let's just keep everything like this and then click apply and close. And as you can see, all the requests we see now are for gin and juice.shop. And very specifically, we're also filtering out those JavaScript files, CSS, images. The only images we're actually getting now are SVGs. If I go back in there and I add a comma and then SVG, and then click apply and close, those should all disappear now. Now we have a few MP4 files, some WAF files, I never know how to pronounce that. And then we have other requests, right? So regular requests to certain HTML pages. That's how the settings mode of the filter works. That's how it's worked for years. Now we have this Bambda mode. If you just click Bambda mode, it'll just default to return true, right? So that's going to effectively clear out all of the stuff we've done in our filter. It's just going to show absolutely everything, because the way the filter works in Bambda mode, it runs whatever code you have here for every single row in the HTTP history. And if you return true for that row, that will show the row. If you return false, it will hide the row. So a return true is just going to return true for every single row. And so if we click apply, let's not click apply and close, it will show every single request and response. But if we go back to settings mode, let's click apply again, and we see we only get those gin and juice shop requests being filtered. So one thing we can do is we can use this convert to Bambda button. And what it'll do, it'll take all of the settings that we have configured here, and it will create a Bambda that basically does the same thing. So that's pretty cool. If you just want to filter something using settings mode and then represent it as a Bambda, you can just click convert to Bambda and it will write a Bambda for you. Now, personally, I think the way it writes these Bambdas is a little confusing. I understand why it does this way, because this is just the easiest way to programmatically take the settings and represent them as a Bambda, but it can be a little confusing. Let's just walk through it a little bit. So the first thing it does is it defines a variable called path, right? And then what it's going to do, it's going to take this request response variable, which is actually just a built-in variable that you can access, which is this proxy HTTP request response object. If you don't know what that means, don't worry about it. Just think of it as an instance of one of these rows, right? It's a row of this proxy history table represented as some kind of object in Java, okay? And you don't really need to understand anything more than that unless you're really interested. And if you are, you can go look up the Montoya API, which is where all this comes from. We also have access to a utilities method, which we're not going to touch, but again, look it up on the Montoya API if you're interested in that. So this variable path, we're grabbing the request response variable, which again is going to be a row from this table. So as the Bambda works, it's going to replace this request response variable with whatever the row we're on. We then call a method request on that variable. So this variable is an object. It has several methods. The request method just returns the request, which is in this object. So in this case, if we click on get catalog, right? So this catalog request, if we called the request method on this row, this is the request. Okay, that's what the request method is going to return. The request method, however, isn't just going to return a string. It's actually a request object. So we can call further methods. We can really drill down into that request object. We can call path without query. That's going to return, you guessed it, the path of the request without the query. In this case, this does not have a query, right? The query is basically the question mark that appears after a path, and then anything after the question mark. That's the query. So in this case, the path without query is just going to be /catalog. And then finally, it's going to call toLowercase, which is a string method that converts whatever the string was to lowercase. Okay, so in this case, it's already lowercase, but if this was a capital C, for example, then what this would do is just replace that capital C with a lowercase c. And so that would be assigned to the variable path. And then we have this return statement. And this return statement is kind of confusing, but effectively, we want to return a true or false from the proxy HTTP filter, right? A true means that we want to show the current row that we're on, and a false means we want to hide the current row that we're on. So all we're doing here is we're basically asking a bunch of questions, and then we're sort of doing this logical AND operation. And so all this means is if all of these conditions are true, then we'll get a true, a return true. But if any one of them is false, then we'll get a return false. Okay, so a pretty simple filter. So effectively what we're doing here, we're asking if the request response object's request is in scope. So there's an is in scope method, which just literally checks whether it's matching a rule in the target scope. And if the path ends with JS, okay, so if the path variable we've got here ends with .js for JavaScript files, but very specifically, we have this exclamation point before the conditional, which negates it. So even though this says path ends with JS, you can think about this as path does not end with JS. And so what we're asking for here is really we want all requests that are in scope, don't end in JS, don't end in .gif, don't end in .jpeg, etc. And as long as all of those return true, we click apply and close. Again, nothing changed because we were already on that filter. But let's, for example, take out this last one, this SVG that we added previously. Let's click apply and close. And now all the .svg files are back in. Okay, so that's kind of how the filter works. Just remember, return true if you want to see the request that's being processed. Return false if you don't want to see the request. And so if we just replace this with a return true, for example, click apply and close, it's going to return everything again. But the really cool thing about Bambdas, especially the HTTP history Bambdas, is we can do more complicated filtering. So whereas in this filter mode, we could really only drill down and just get more specific with the requests that we were filtering, we can't do things like, okay, we want to show in-scope items, we want to hide these, but maybe at the same time, we want to see some out-of-scope items as long as they match specific criteria. Let's say we actually care about out-of-scope JavaScript, all right, out-of-scope scripts. But currently, we're only showing in-scope items and we're actually hiding all JavaScript files. So what if we actually want to show in-scope items and also show out-of-scope JavaScript files? Can't do that in the settings mode. You can do it in Bambdas, and let's see how. So we first need to use an if. So we're going to actually do if request. And actually, if you start typing, you'll see that we get this lovely autocomplete menu. And you can just hit enter if you want to. You can actually scroll down using the arrow keys. There's documentation on the right as well. But we want to check if the request response is in scope. And we do that by going to the request and we ask is in scope. And then we're going to end the condition and we're going to go into the actual block of the if statement. And in this case, we're basically saying if it is in scope, we want to return true. Okay, and we're going to end the if block there. So now, if we ever reach this point, we know that the request is not in scope, because if it was in scope, the return true would be executed and no other code in the Bambda would actually be executed. A return is basically a final. It automatically exits whatever line it's on with a true or false. Okay, that's important to remember. So if we ever reach this point, that means that this was not true. Okay, so we're dealing with entirely out of scope requests at this point. And so now what we can do is we can say else if. We want to deal with requests that, let's say, have a response that matches some kind of MIME type, right? So Burp has this MIME type, you can actually see it here, and there's actually a script MIME type that we can use, which is kind of cool. So the first thing we want to do is actually check if the request response object has a response, because sometimes there won't be a response, right? If Burp sends a request and the server times out, there won't be a response. So we want to do request response.has response. That's just a function which returns true or false, whether or not the request response actually has a response. And then we're going to do request response.response. And then we want MIME type dot equals. And then we can actually call, there's a special MIME type. I actually just press control. So if you ever don't see, right, if you ever don't see the autocomplete come up, you can actually force it to come up by holding down control and pressing space. So I just did that, and now we say, okay, there's a MIME type class, and we can call script. So there's actually a script attribute, and so we're basically saying if the request response has a response, and the response's MIME type equals whatever the MIME type script is in Burp, then we can end the if, go into the block, return true, semicolon, and there we go. We're returning true in two different circumstances, right? Whether the request is in scope, and if that's not true, if that's not the case, whether the response actually exists and has a MIME type that equals the script MIME type, returning true. Otherwise, so we could put an else here. We could technically do this. We could technically do a return false like this. That would be fine. However, honestly, you don't need to do this. What you can just do is come down here and end with a return false. And this will just basically be a catch all. And so now if we apply and close this, you can see, if we scroll down, we get all the requests for ginandjuice.shop. Okay, absolutely every single one of them. But if we come back up again, we see we do have some scripts from Google, right? So these are some Google G-static scripts. We also have JSON. So JSON does technically count as a script type, a script MIME type in Burp Suite. So just be aware of that. But this is just an example. And so here you go. Now we can filter based on whether a request is in scope or whether there's some kind of out of scope script being used. Okay, so I'm going to actually reset this and we're just going to do a return true now. Apply and close. Next thing we're going to talk about is custom columns. Now, custom columns are only available in Burp Suite Pro, unfortunately. So you cannot use them in the Community Edition. However, there are some good opportunities for using them. I personally don't use them as often as I really should, even though I do have access to Burp Suite Pro. However, there are a few people I know on the Portswigger Discord that use them a lot, and I have taken one of their examples which relates to GraphQL, which is why I have this GraphQL request loaded. So this is from one of Portswigger Web Academy's challenges, and you'll see in this request we have an operation name, get blog post. These operation names are sometimes useful to extract, and so what we're going to do is create a very, very simple Bambda for a custom column that just looks through the request and extracts an operation name. And it's actually one line of code I'm just going to copy. What we do to create a custom column, we go up to these traffic light icons here and go to add custom column. We're going to name it, let's just name it GraphQL op name. And so custom columns can return a lot of things. Mostly they're going to return strings or potentially numbers. You can technically return any object, only some objects can get displayed in a table. So I would stick to strings or potentially numbers like, for status codes. But we're going to select all of this and just paste in this. And this is all you need to extract the operation name for a GraphQL function, assuming it's using this pretty standard syntax. If it's not, then yeah, we're going to be in a bit of trouble. But let's assume that it's actually using this syntax just to keep things a bit simple. The way this works, we're using the request response object again. We're calling the request method, which is going to return the request as an object. And the request object has this parameter value method, which basically extracts the value of a parameter. And it does this, you pass it the parameter name that you want. In this case, this is operation name. And you can also pass it the parameter type, because obviously a request can have different parameter types. It may have a parameter in the URL. It may have a regular body parameter. In this case, this is a JSON object. So we're going to say, okay, the HTTP parameter type is JSON. And if we click apply, you might think, okay, nothing's happened. It's actually added all the way over to the end here. So I'm actually going to drag this custom column. We're going to expand it a little bit. And there you go. So this was the request. It found the operation name, get blog post, and it displays it. And you can see we also have this get blog summaries, and there's another one, all right, because this application was sending a bunch of GraphQL requests. Everything else is a null, and that's because this Bambda ran against these requests and it didn't find anything in the body that matched the condition that we were extracting. So it's just going to display a null. But you can also sort by these columns. This is a really cool feature of custom columns. The fact you can basically treat them as any kind of column, right? They're just a regular column in Burp Suite's HTTP history. You can also use them in the logger as well. Okay, so you can add custom columns in logger if you want. You can also do view filters with Bambdas in the logger as well as the proxy. Okay, and the final feature of Bambdas that we're going to talk about very briefly, because I did talk about it a lot in my last video about Burp Suite, the match and replace Bambda rules. So we're only going to cover one example, and it's the same example I covered in the last video. But effectively, with match and replace rules, what you can do in previous editions of Burp, you would be able to do these regular expressions or even literal match and replace. So match a regular expression, replace it with something else. Now in Bambda mode, you can run custom Java code against either the request or response and do modifications to the request or response in all this code, which is really cool. And so we're going to use the one that I honestly think was the most fun last time. It's this one. So what this does, I'm just going to make the screen a little bit bigger. What this does, it operates on request Bambda, so it will change the request, and it's just going to add a new URL parameter called rand that contains a random string. And this can be useful if you're doing any kind of cache busting. It can also be useful if you need to have some kind of random element added to your request to keep requests unique for some reason. This is a simple Bambda. It's going to operate on every single request that goes through the proxy. And so what happens is we're going to define a string called chars, and that string is just going to literally be a string of all the hex characters, right? A to F, 0 to 9. We're then going to define a string builder, SB, which is a new string builder. String builder is just a special object that builds strings, right? One of the nice things about Java, everything is kind of named sensibly, I think. A lot of people are going to disagree with me, but I don't care. If you want a random number generator, you create a random object, a new random. This is the random number generator. It's not secure random, but we don't need secure random. We don't really care about that right now. What we're going to do then is use a for loop, and we're going to iterate over the numbers 0 to 9 because its I is less than 10. So 0 to 9, 10 numbers. And then for every single iteration, we're going to append to our string builder a random character from this string. Okay, so effectively all this code does, it uses the random next int, so selecting an integer from the set that matches the length of the string, and then just convert that back to the character, right? So we're randomly choosing a point in this string and selecting a character from it, and then appending it to the string builder. Then we're going to create an HTTP parameter called p using HTTP parameter.url parameter, because what we want to do is create a new URL parameter. We're going to call it rand. That's going to be the name of the parameter, and the value is going to be sb.toString. So the toString method on the string builder object is literally just going to take whatever's in the string builder buffer. I'm not sure exactly how it works internally, but it's going to convert that buffer to an actual string object, and that's going to be set as the value. And then we just have a simple return request response dot request, so the current request. The with parameter method basically remakes the request with whatever added parameter is here, and then we're passing it p, which is the new HTTP parameter. We can test this by clicking test. As you can see, this post/update in the auto modified request now has this random string, and we can keep clicking test and we get a new random string. And if I click OK and make sure it's enabled, it is good. We go back to Burp, the HTTP history. Okay, we are returning true. If I just refresh this now and go back, we should see, hopefully, I need to sort properly. There we go. We should see a bunch of requests now with that new URL parameter with a random string attached. Pretty cool, right? And again, that is only in Pro as well, unfortunately, but it is a pretty sweet feature. If you're not using Pro, you can still use regular match and replace. And if you want the Bambda-like functionality, it's pretty simple actually to create an extension that does kind of the same thing. Thank you so much for watching. Hopefully now you'll feel more confident writing your own Bambdas within Burp Suite. If you enjoyed this video, please remember to give it a like, subscribe to the channel, and I'll see you in the next one.